Okay. So what we're going to do, we're going to run you through real quick what phenom science kind of looks like, and we're going to talk about phenoms and how that relates to me and what I do, and what I do when you bring an idea to me. Kelly's going to tell you how she kind of builds out a unit based on a storyline, based off a starting phenom and then investigative phenoms. So just to start out, I'm going to go through my process and then I'll let you talk. So I was told that you guys were working 6th grade, you're working on cells, 7th grade, you're working on weather, and in 8th grade, you're working on molecules. And this is what happens at my desk. So this is how my process starts. You tell me what you're working on, and it may be more specific than just the basic standard, but what I'm going to do is I'm going to start a chart. I'm going to look at the standard itself, and I'm going to look at the DCI and read that so that I have an understanding of exactly what you need to be getting across to your students and what your final assessment's going to be on whether or not they understand that standard. And then I'm going to start doing some research, and I'm going to look for anything I can that relates to that standard. And then I'm going to test out most of those labs to see if what I'm finding relates well enough to what you need to do. Today we're going to focus on weather, and we're going to do a little bit of molecules. I'm going to run you through some phenom and let you see how we build off of that. All right? And you can see we're going to work mostly on weather.
Any questions at any time?
You can see we're going to work mostly on weather because that's where I've been focused the most. I started playing with it and I got a little overzealous and involved. Kelly and I were together about almost 3 hours last night playing with weather. So, and if you have any questions through this process, don't be afraid to ask. It can seem really overwhelming. Don't take it all as it has to happen all at once. It's something that develops, and it's something that you develop yourself, and your students help guide that development. All right? So, Kelly, you want to talk about a couple of years ago, we presented at Michigan Science Teachers, and it was based on developing a storyline. And Kelly's going to run you through real quick what a storyline looks like, and then we'll get into the investigative process with some phenom. Okay?
Have any of you used a storyline?
You're going to have to talk louder so I can hear you.
Have you used? Okay. So I am by no means an expert on this. I've been doing this for 8 years until this day. I cannot develop a good storyline for life science. I just can't. I don't know. But this storyline I did probably took me a good solid 4 years to get it the way I wanted it. And looking back, I think I'd still change parts of it. But basically what you're doing when you do a science storyline is you are using an anchoring phenomenon, like an overall anchoring phenomenon. It's going to be like your big idea. And you tell the kids nothing about it. They have no information. And you present this phenomenon to them and they come up with questions. And then those student questions drive your unit. So the rest of your lessons are going to be based off small investigative phenomena. These would be like your labs. Okay? Till they get to the end and they go back to the original phenomenon, and they should have all their questions answered and be able to explain the ideas behind that original phenomenon. So I'm going to take you real quick through one of my 4th grade ones that I did.
And you guys should have these slides so you can go back through and read them. And
This was other stuff that I threw in here for a presentation at Deep. So my original phenomenon was...
I don't think those videos were working in the slides. Did anyone have that problem?
Oh, really?
Some of them did and some didn't.
Okay,
Okay.
all right, so I wasn't...
So basically what it is this. These are popsicle sticks weaved together, and when you release them, they go flying. And so I had the kids try to explain what was going on, and they had all kinds of ideas. They thought there was magnets. They had no idea, and they came up with all kinds of questions about it. So, and I didn't tell them the answer to any of it. I said, we'll find out. So the first thing that we had to touch on was just what is kinetic and potential energy. So we did some little explorations. I gave them rubber bands, and they got to explore with that. So then we went back to the original phenomenon, and I said, where's the kinetic and where's the potential energy in that? So then they were able to explain in the sticks phenomenon, where's potential and where's kinetic. Then we talked about energy coming in different forms. And then we went back to the original phenomenon. Are any of these energy sources getting released? Well, they figured out heat and sound. Okay. So basically, I'm not going to take you through all of this, but every time we did a little exploration about energy, they always had to go back to the original phenomenon and see how it fits in. And then we got to a point where I gave them something new to apply it. We made pinball machines. So in these pinball machines, they now had to take the ideas that they were learning and apply it to something new. So we did the pinball machine step by step, like little by little. So the first thing I gave them was the launcher, and we talked about kinetic and potential energy. We talked about sound. And then as we went through more concepts, we always went back to our original phenomenon. So here they're learning about circuitry. We always went back to our original phenomenon and applied what we've learned. How does this relate back to the phenomenon? So then by the end, they were able to answer all these questions about energy as it applied to that phenomenon. They also were able to apply it to a new concept. They could also explain all these ideas in a pinball machine. Now you don't have to do that. That's just kind of something extra we threw in. That's kind of how I assessed them. I actually made them take their pinball machines out in the hall and videotape themselves explaining all the energy concepts they've learned and where it falls in here. And then that was a really good assessment because you can really pick up on the misconceptions. So that's basically a storyline. Start with big phenomenon, use little investigative phenomenons, and have them keep going back to the original phenomenon. Can they apply that to that situation?
Okay. All right. So what we're going to do, we're on a time crunch, is first thing I'm going to do is I'm going to take you through a driving phenomenon.
Have the lights on or would
Yeah, let's turn them on for right now. So we're going to start with weather, and we need a wow factor. We want these kids I'm going to adjust that so you can see this
Do you
too.
want the little worksheets so they can start filling out their questions? And
We could. We have a framework.
I'm sorry.
So we developed a framework for you to do all of this.
I'm running.
And she's going to go pick them up. You're going to get a copy of this, and we'll share out this document with you. And it's a framework that takes you through this whole process that Kelly's just explained, that you can kind of fill in, and then you can base whatever kind of documentation you want your students to have based on this framework, okay? Sometimes you may need them filling out journals. Sometimes you may want them doing video documentation. So weather. So we need a driving phenom. And what I'm going to bring to you today was based on no collaboration other than we had some last night. So generally I like to do these with you guys because you know what direction you kind of want to go with the standard. This one I kind of I went by the seat of my pants. So I read the standard, I read the DCIs, and this is what I have. So I have a chamber here, and this is how I would present it to a class. I have a chamber here, and I have two thermometers, and I have some sand in the center, and I'm going to create a weather event, okay? We need the snow from outside.
Okay, you got a jar?
Right up, no, it's already packed.
Oh,
It's
you
sitting,
got it.
the beaker's sitting out in the snow, outside the door to the right.
Okay.
All right, so the standard reads that we need to be able to show wind and that current, water currents, and a lot of that is based on, sorry, that was in my face. A lot of it is based on the fact of ocean currents, what causes ocean currents, what causes wind, And so this is kind of, I came up with this. So I did a lot of research. I saw a lot of different models out there. I didn't feel like they had enough wow factor, so this is what I came up with. And if you don't feel it's right for you, you don't have to use it. You don't have to use anything I do. Or you might want to make this better. That's what I'm here for. So we need to introduce. Woo! Okay, this is about 500 degrees. So this is our hot desert sand. I just put it in a pan of hot sand, about 500 degrees. Okay? Kelly's gonna bring in our iceberg in just a second.
I was like, where's Waldo?
You found it.
I'm running around.
So what I have here is a beaker, and it's packed full of, luckily, very, very cold snow. So this is our iceberg. In the front of my model here, I got a lot of snow on the bottom. On the front of my model, and I did this just since I got here, I actually incorporated 2 thermometers, one on either side, because I want to be able to see what's happening in here. Now, this has got a lot to do with temperature changes and motions, and I want to prove that wind exists. Okay, we know that air pressure exists. We can prove that with this. There's air in here, and I can prove it. There's my air pressure. We've all done that in kindergarten or for elementary, but we want to be able to see it. So what I'm going to do is I've got some sawdust here. I'm going to light this. I'm going to put it in. It's going to create smoke. It's going to smell in here a little bit. But what it allows us to do is see the wind currents.
Michelle, does this tip?
Oh, it might.
Don't drop it.
Oh, you want to put it down?
You can't see your tank that long.
Lower the legs.
Oh.
So I got to get this going first.
Here, hold on.
Okay.
You got it, just in case of it.
I got
And
it,
this
yeah.
is, all this is one of those little sticks you use to light firecrackers.
A little bit lower.
Now, I need to contain it. I don't want the outside air to affect it. This is what I had set up for the kids. All right, I want you to take a good look. Just watch it. Everybody's going to gather around. You want to set Beth over here?
Oh, here, Beth, you want to come closer?
So, we're just going to watch what's happening. Here, I'll scoot it back.
You want her to come hang out with me?
Yeah, there we go.
We're just gonna we're just gonna watch what happens. So we need to be able to see things moving in here, so we can add some lights.
You want me to turn the light on now?
Yeah, would you? And it's a little hard to see from a distance the closer you get. So you're just gonna make some observations. So right now you're not telling the kids anything other than we're just observing. What are you noticing? And all I'm asking them is to observe what they're seeing happen in here and make 3 wonderings. Write down 3 things about what you're seeing or what you're wondering. And I could have better light in there. I'm trying to get the right lighting.
So-
That's the one thing I haven't got worked out yet.
Literally, like, so I went and played with this with Michelle the other day. So, like, what are you guys seeing right now? Like,
Smoke
pretend.
looks like it's going over by the hot sand.
So, what direction do you see the smoke moving?
It's rising on the hot side, and
Right.
it's moving across the top to the cold, and then I can see it dropping back down on the other side of
That's
the cold.
what's going on.
So you're saying it's kind of rolling and dropping on the
Yes.
cold side, and it's rising on the hot side.
I agree.
You see anything else?
Notice anything.
Kids will recognize a lot more in this than we do.
I bet.
Because we kind of have some preconceived notions about what's happening. So what would you question?
Or is there more motion on the
Right on the hot side.
hot side, and
Oh,
less
okay.
motion on the right?
Alright.
I'm drawing it over there.
So a question for me when we did this is I was like, why does the smoke go up on the hot side and it looks like it falls on the cold side?
Oh, I see heat rises. Well, that's
Beth,
okay.
you got anything? Can you see
Can
it?
you even see it? Yeah.
Can you?
Kind of. But
So basically what's happening is the smoke is in the center, but it's being pulled over to the hot side, drawn up, and moves across, and it's coming down. Now what we're witnessing is the development of wind, because it's circulating the air. So the connection as a teacher, and you would never tell them this, but what you would be able to come back to on this is, so you have your equator, the hot portion of the world, and you have your Arctic, and now you're starting to see those circulations of wind currents, okay? Or any other place that you would have warm and cold, but that's the most drastic. Because wind is what we're trying to talk to them about, okay? So that, and you would start with this, and you would start with your wanderings, and then they develop models of what they think is taking place
So this
independently.
Yeah, so this is like where they draw the before. What did it look like before? Okay, now what's going on during?
Yeah.
And then when after, however long you want to give them, what's happening after?
So, like, if you left this going for an entire class period, there is something kind of interesting that happens at the end that I didn't even see until I worked with Melissa. When we talk about the Arctic caps and the
Ocean? I don't
no,
Glaciers.
Climate?
glaciers and climate control.
Climate-
There it
climate
is.
Yeah.
zones.
Okay,
Climate
sorry.
zones.
My brain's going
One
too
word,
fast.
starts with.
Starts with, yeah. Okay, so this would go all class period, have the conversation, that's kind of that. And then you do draw a model of what you think's happening in here, independently. You could then break off in groups and compare and contrast, then come up with a group model, and then come back and do a class consensus model. And that could take you a couple of 3 class periods, depending on how involved your kids are. But in the meantime, this is going on in front of them. So they've got something they can always reference back to. Okay, so that's part of that. So another part of this unit, so we have clouds in here, and here's another wow factor, and this one's kind of just for fun. So we're using smoke to simulate the wind and the clouds. So here's a little tie-in.
Well, you say
What-
it's for fun, but I would call this an investigative.
So this would be an investigative, that's correct. I say for everything I do is for fun. So what I have is a 2-liter bottle, and inside here, and you can do this with water. Some of you may have seen a cloud made in a bottle with water and a blown out match. You can do it, it's much more visual if you use a little rubbing alcohol. So I have just a tiny bit in here. I'm using 70% alcohol because it has more water content. This is much more visual. I have here a bike pump, and I've modified a tire valve to fit with a plug. I can plug this right off. So I have standard air pressure in here. This is what's all around all of us. I think it's what, 14.7% PSI, is that right? Or 14.7 PSI. We're gonna make this 20 PSI. So we know that that's in there, we do that. So what happens when high pressure and low pressure move against each other? That's the question. What happens when high pressure, so I have 14.7%, now I have 20%. What happens when high pressure and low pressure move against each other? What happens? What do they create?
Great clouds.
Why? What happened? What's going on with the water molecules to create a cloud when high pressure and low pressure meet?
So this is where your kids are going to have tons of questions too, because I was doing this last night and I had so many questions.
So does the molecule like speed up to a point of going in from a liquid into a gas?
The friction of the high pressure and the low pressure molecules is what it causes a condensation of the water molecules. And that's why it
Let me
happens
just
so
say that
aggressively.
One more time. Say it one more time.
The
I'm sorry.
high pressure and the low pressure friction of the molecules, you can read up on it, it's better than I can explain it.
Okay.
But it has to do with the molecules, the low pressure and the high pressure, and the friction of them. And because they heat up when they pass each other so aggressively, it causes the condensation that causes the cloud.
So then we got in a conversation about high pressure and low pressure and thunderstorms and the friction that's caused with that. We went off on tangents.
What's interesting about this, so after you investigate that, so, okay, it's a foggy morning, right? What just happened? My cloud went away.
And your kid's brain's just turned on. Like, what?
Definitely.
I just made it disappear. Or did I? So here, that is your investigation.
So then-
Why is that happening?
And you're thinking in your class, like, the kids' minds are just going crazy at this point, and so you're forcing them to get that stuff written down, get your questions out there, and then your student talk, they're talking things out, they're using their prior knowledge, and then you start adding things as they're presenting out to you guys, then you start putting in those pieces of information that you need them to know throughout the unit.
Okay, so another part of the weather unit is landforms and that air movement. And the other thing you could do is tie back into this. How could we introduce landforms into what we see here happening here, and would it affect the current, the wind currents? So could we make clay mountains or hills? Could we add trees? Would that have an effect on it? What if the sand wasn't so hot? What if we didn't use as much ice? How can we change this model to explore it deeper to meet those DCIs that we need? Okay? All right, moving on quickly. So the next thing I have that ties into this, so we're going to talk about ocean currents a little bit. So again, when we talk about ocean currents, there's a couple of different models we can do. And I'm going to do this one in a jar just because it doesn't take up as much space. I have this tank, and it's just a demonstration tank. It's clear. And what I would do is fill this up about 3/4 full of water, and I have made up some salt water. Now what I won't tell them is that fresh water and salt water obviously have different densities, all right? And that has an effect on the ocean currents.
Drop it again.
When those two meet, that affects the currents. That's what they're going to learn. But as a demonstration, here's another just investigative phenom. So I have just regular water in here, tap water, and I got a little made up eyedropper. And I'm going to take some of my very, very salty water. This is just water and rock salt, and then I added blue dye so you can see it. And I'm going to slowly introduce it to the water. So this is my fresh water and my salt water's mixing. And it takes a couple of minutes to get it all. Otherwise it just makes a big swoosh and it takes forever for it to settle. You should probably shook it a bit.
Is both the salt water and the fresh water at room temperature?
Yes, both are at the same temperature. You could do this where your salt water is cold to emulate the fact that it's Arctic water, because Arctic water is saltier. But that's something you could discuss and explore. So we're doing room temperature, fresh water, salt water. What if we did make them cold? What if one was cold and one was warm? If the fresh water was warm and the salt water is cold, would the salt water then rise, even though it is more dense? There's an investigation right there. So obviously you can see the density of the water. The salt water fell to the bottom. I had one sitting on my desk pretty much all day, and it never did mix. Now, what I would have done is done it in a chamber like this, on a much bigger level, and having this, and you would have your salt water in the bottom, your fresh water on the top, and then talk about wind currents. I'd introduce a hairdryer to the top of the water to create waves. So I'd bring in that wind that we created in the original phenom, and create a wind in here to see if it affected my salt and my fresh water. Would I get any movement in those? Would my cold and my warm start to mix? And then that ties into our, Kelly?
Investigative.
An investigative, but the map with there's another old lady moment with the currents, water currents.
Oh.
Sorry.
No.
We were looking at a map. There's a really cool map we found that shows how it moves up like to Antarctica,
Oh, yes.
and then it flips and it talks about the
The
salt
ocean
content versus pardon?
The ocean current?
The ocean currents. There it is. I get to talking too fast. I lost my cap. I don't know what I do with it. So
It's right here. Gotcha.
not to say these are the only models that you can have for this, or the only investigations you could do. These are investigations that are a start point, and this is where your students could then come in and say, hey, what if? And then that's where you say, hey, Bilby, we got a what if, and I come running, okay, with whatever I've got. So you can see just in this what I have that I can help you with, okay? My job is not to teach your unit, it's to make your unit easier to teach by bringing you the things. Not easier. I wouldn't say this is easier, but it's a lot of fun. The conversations are just amazing. So, any questions on this? Hello. All right. We're doing pretty good. Anything you want to add here?
No.
Anything you want to add?
No.
No? I didn't miss anything?
Just that by the end of all the investigative phenomenon, they should be able to explain every concept that was going on in there.
Yeah.
And how all these
Yes.
investigations tie back
Yeah.
into what we see going on here, yeah. So everything's always coming back to this.
Yeah, it's bringing everything full circle.
Exactly. Okay? Now you're totally like, yeah.
No, not at all.
That's too
No.
much.
No, it's not actually.
So the thing that, like, and I'm on weather right now, that, so, you know, we all have our strengths, like, oh, I love it when I get to do the whatever unit.
Right.
Weather is not my thing, okay? What I do enjoy about it is there's all these little sub phenomenons that are, you know, friction's fascinating to me and convection currents is fascinating to me, it's not weather, okay?
Right.
So, I'm looking at this chart, and there are so many subcategories in the weather. I'm like, oh,
Yep.
all this stuff, are you kidding me right now? So, you know, it's densing, and it's evaporation, and it's pressure, and it's wind, and it's, you know, so this is helpful to, you know, to put together. This looks more demo-driven
Well,
than.
it's demo driven because of COVID.
Okay.
There are a lot of times, like the density, we could do this independently. They can do this in a water.
Sure.
Man,
We could do this in a water
you
bottle.
made me run down the hallway. I'm a
There
little sore
are-
right now.
There are times when it is demo driven,
Yeah.
and there are times when it's independent
Sure.
or it's group. It just depends. When you're doing something big like this, demo is the way we have to go. I don't have, you know, 30
yeah,
fish tanks,
absolutely, yeah.
you know. But when you want to do a density lab, I mean, we can do these in water bottles, beakers, anything. This is something they can do. So,
Yeah, it
And-
kind of just depends on the nature of what it is, whether you can put it in their hands or do a
Yeah.
demo.
right. And we can do less right now than what we've been able to do in the past. And a lot of times, you may think it's demo driven. I may be able to come up with a way that it's not. That it's a personal. Like we did chromatography back before we went out this last time, and that was all independent. They did that investigation all on their own. Every student got to do that, and it was huge. So, all right, so we're just gonna set this up. We're gonna do one more little playing. So that's kind of weather, and you can have your work on your questions or whatever. Next one we're gonna do is we're gonna go into chemistry, and we're working on molecules. Ooh, table's hot. And we're working, it's for the most part molecules. I didn't read this one quite as deeply as I did weather, because like I said, I got to playing too much. But what we're gonna do is we're gonna start out with a really simple investigation. This could be your driving phenom, or it could be an investigative phenom. So everybody's got a plate. Everybody's gonna get some milk. Open your milk and pour in about half plate full. And some of them may say, "Oh, I did this in 2nd grade." Well, that's all right. But you know what? I bet you didn't look at it the way we're gonna look at it today.
Right.
Okay?
Did you say half of it?
Yeah.
Have a plate.
Yeah, about half. Fill your plate up. Put some milk in it. You want to cover it up. Close to. It's in that white thing right there. Okay. The next thing so we've got milk. Next thing you're gonna add, you're gonna take some food coloring and put in 3 drops. And then we'll switch up your colors, and everybody's gonna put in 2 more drops. Or put
Anywhere?
in just a couple of drops.
Okay.
Just a couple of drops, and then we'll give you another color.
Should we space those out by color or
You can
anywhere you want?
put them where you want. You can put them in the middle. It's up to you.
Yeah,
This
okay.
is your investigation. You build it. Now, in the meantime, as you're building this out, we're gonna document what you're doing. So where you're putting your dots
Oh, okay.
is important in your documentation. Okay? So you'd be logging the size of your plate, how much milk you used,
I got orange.
Oh, I got 3 on that one. Oh, well.
how much
This one.
milk you
Are you just doing
used,
all colors?
yeah,
Just those
Okay.
3. You got
3.
what materials we're using, a Q-tip. Okay? And then we've got our dish soap. Kelly's gonna come around with the dish soap. And you're just gonna dab your Q-tip down in. You don't need a lot. Oh yeah, you don't need way.
I'm special
You
needs.
just
Sorry,
need,
kids are gonna do that.
Sorry, I'm like
you're
the
just
video
gonna
is
need
terrible
a
now.
little bit of soap on there. Okay? Okay, can you see what, oh yeah, you can see her plate.
I didn't
And,
get the whole thing. Should I have got the whole Q-tip?
no, you're
Nope,
fine.
you're good.
Alright, so you're gonna touch your Q-tip into your milk and make observation.
Anywhere?
Anywhere, you do it.
Oh.
Make an observation. What happens?
That was cool.
You know, why is it all pushing?
You, oh, what'd you say?
Oh.
What'd you say?
Why is it all pushing away?
Oh,
Look at how
there is
pretty
my
that
driving
is.
question right there. Why is it all pushing away?
That's so cool.
Why? Why? Are your colors mixing?
No.
What happens if you take your Q-tip out and let it set for a minute? What do you notice?
And remember, if this is your anchoring phenomenon, you don't want to give any answers.
Yep, I'm not gonna.
It's a
Yeah.
lot of fun.
So she's over here documenting in between each touch.
Yes, I am.
Yes, it is fun. That's part of it. Look how quiet the room got. You're fascinated.
Mm-hmm.
Bilby and I ended up coming up with another experiment off from this. We were like,
Well,
I
this
wonder
is
if
what I-
it goes like underneath the milk.
Well, because it kind of looks like it is. It looks like it's flowing like like it's in layers.
That would be a good observation to write down. I
Mhm.
see it moving up from the bottom or flowing in layers. Ooh, yours is like making bubbles.
Which I'm assuming is soap on the bottom.
Oh, what'd you say?
Assuming that the way it's coming up like as it bubbles like that, it's probably soap that's stuck to the bottom.
The soap stuck to the bottom possibly? Okay.
Oh.
All right. So then where you would take this is, so we're gonna write down those ideas, those questions. We're gonna get those onto a chart. We're gonna draw some models. We're gonna do some documentation. And then we're gonna start exploring. One of the explorations in this is a video that I have pulled up here. Kelly, you wanna hit that? And we would watch just the first part of this video. We can hear him.
Then make colors move in milk. You don't need much. You just need some food coloring,
He's gonna
some liquid
tell you the
dish
demonstration
detergent or
real
dish
quick.
soap, a little plate that's kind of shallow, some cotton swabs or Q-tips, and some milk. In this case, we're using whole milk.
We
All you need
use
to do is take the milk
skim milk.
Yeah.
Or
and
low
you
fat.
pour it into your plate, and then you take your food coloring, add maybe 2 drops
Oh,
to the
can you
center.
turn her?
of each color, using blue, yellow, and then red. And then you take your dish detergent and a cotton swab with Q-tips, and you put some detergent right in the center. Just barely touch it and watch what happens. It's pretty cool. And you can leave it there and watch the colors move, or you can dip it down to the bottom, because sometimes the food coloring gets to the bottom of the milk. It's a little heavier in the milk and it might be at the bottom, and sometimes you get some good reaction that way. You can also take some more dish detergent and touch the side of the plate, and sometimes you get some extra action. In this case, it's doing pretty well.
So you would show this after you've
To
done it.
understand what's going on here, it's pretty tricky actually, but if you looked way down into the milk, as close as you could get, all the way to the molecules that the milk is made out of, you'd see that it's made out of water molecules and fat molecules and protein molecules. They're all molecules made up of different atoms, and they all interact with the dish detergent differently. The water has positive and negative charges on it, and the fat has no charges, and the protein is very complicated and has positive and negative in different places. Detergent molecules have a negative charge at one end and no charge at the other. So when you put detergent on the surface of the milk, the negative end of the detergent molecule attracts the positive end of the water molecule, and the detergent zooms over the surface of the milk and pushes the food coloring to the edge of the plate.
Okay, all right, so that's where we'd stop right there. So now we know we're talking about molecules, right? Now I said you're using 1% low-fat milk. Based on what you just heard of molecules, what do you think? Give me a diagram, write me a description of what's happening in your plate. What do you think's happening based on the information you've been given so far? Okay, that's where you would start with this. Then what I do is I come back, I might do, maybe give them some cutouts of molecules, have them piece together what they think's happening, the charges, do a diagram, label it out. That'd be another one. Kelly, you got something you want to throw in there? Or you following? Okay.
I don't know, this isn't my unit.
Not her unit. The other thing you could investigate is, so if this is 1% milk, is it different with whole milk?
Right.
Is it different? So this has less fat in it. So what if I had whole milk? What if I had heavy cream?
I would wonder about different detergents.
And different detergents. What about different detergents?
And we also talked about the different types of food coloring. So Bilby and I, when we were talking about this, and like RJ, like what you were saying, where this was more of like a modeling, this we could have totally given like different groups, totally different things. Like this group got, 1% milk. These guys got skim. These guys got 2%. These guys got this type of dish soap. These ones got like the gel food coloring, just to see, and then they're all coming back and having to talk together to see.
I'm trying to pull the stand up. I'm listening to what you're saying. Go ahead.
Here, I might have it right here.
Because
Here you go. Right here. So this is just part of that standard. This is not the standard.
Sure.
This is just a quick investigation, okay? Don't think that, and this might not even be your anchoring phenomena. It could be an investigative phenomena.
Well, no, it's great.
But it's one you can build, what I like about it is one you can build out in many different directions. You can look at the positive and negative charges of the molecules, you can talk about the fat content and things, and adjust that, see what the effects are, change the various constraints and variables. What if it's less milk? What if it's more soap? All of those types of things. One of the things that Melissa and I did was we were curious. We saw that it was coming up from the bottom, so we put the milk in a beaker. We wanted to see, could we see it coming like up the sides of the beaker?
Could you?
Could you?
certain colors.
Certain colors.
Certain colors did, and so then we were thinking like, okay, well, like maybe the
Density.
different chemicals that are in the certain colors have different charges or density
I
or
could go
something of
crazy
that.
on this one.
Right.
I start thinking about all kinds of things. with
And
the
it could be
colors and
because we're
density.
using our wonderful 1% milk, which is basically white water,
Yes.
versus something that would have more fats and proteins in it.
Right.
Well, what was the answer? Did they say that the charges of the water in the soap and then the milk,
Yeah,
there was
so
no
then you
interaction
could,
with the color,
you could go ahead and
colors,
finish it
right?
up, yeah, but yeah, what it does is your charges are gathering. your-
Just with the soap and the
and
water,
that-
there
yeah,
shouldn't be
so-
any interaction with the food coloring though, right?
Well,
I can't remember. Was the food
your
coloring?
food coloring is liquid, it's not a solid,
It's not solid, okay.
so how much water content's in your food coloring?
Okay, Yes, so
But
you're gonna have
mostly what
trace.
you're moving are your fats and your proteins.
okay. But that's what's flowing.
Yeah, and you can see, if you leave the soap stick out, because we're using higher water content milk, there's less fats and proteins in it, that it'll actually start to like come back in like these shards of color, as opposed to like this milky mix up you have now.
Right.
You'll actually see the dyes start going back into the water of the milk. So that
Did
was
you leave
kinda
it out
interesting.
all day the other day? For a while.
I left it out all night. I was too tired, but I went home. I clean up in the morning. So anyway, so that's just one for chemical. I just want you guys to know this is the kind of stuff I can help you with,
Yeah.
and I'm willing to sit and chat. You
I
just
think
gotta
this
holler.
one's cool. The thing about the you're on atoms and molecules. You're in the middle somewhere. So they mentioned you do the ball and the stick models, and I know they've done some of these in the past, and in doing the right now I'm trying to introduce them to some ideas of why there's a reason they fit on the periodic table in a way, but I'm not teaching the periodic table. I'm using another device to show these patterns. But this is cool for cause and effect,
Yes,
right? Like there's a cause and effect between the charges.
right.
It doesn't necessarily
Doesn't show you how you're building them out.
no, but it hooks you into
Mhm.
Gets you
It
interested
gets
in
you
molecules.
Going on there.
something's
Yeah.
going on there, right?
Something's going on there.
Yeah.
And then that's where your investigation starts. You got them. Something's happening. And now you can start getting deeper instead of going deep and then them going, oh, got a clue and I don't care. Now suddenly it's something they can relate to.
Yep.
When you're talking about building out, making models, FET has really got some good simulators for building out, off of developing your molecules from the chemistry
Yeah,
chart.
those ones are great. They got
Yeah.
nothing on weather.
No, they don't have anything
Oh,
on
God, they
weather.
have nothing.
Yeah, they got nothing on
No,
weather.
they have some good stuff on the atoms and molecules.
Yeah.
I know, I
So-
felt so bad. Brandy found the super cool thing that was weather on like new planets, and so like she had it all up and ready to go, and I went in to observe, and nothing worked.
Yeah.
So
Oh,
I
God.
was like, ah.
I got over here and a lot of my stuff wasn't working, so.
So
Yeah, so I'm, and I have time to help you with finding these things, but I don't know what to look for until you tell me what you're looking for.
yeah, you
What your
have
like
like
not
you
even
are
what you're
not.
looking for, but what your direction is. And then I'll bring you everything I can find in that direction. Okay? And some of it is gonna be totally, you're gonna go, yep, not doing that.
Well, and I would highly encourage you. Like these two have been telling me all the time. Like we get together and we just play. I'm like, what the heck
Yes.
is you get together and just play? Like I want something to go back and do with the kids. And so literally, like she was like, "Come on over, and we're just gonna play." And we with these, I said, "Okay, well, can we play with stuff with these 2 units or these couple units that our teachers are going into?" And so we got over there, and we started with this, and then we went here, and then there, and here, and we ended up creating stuff that we were like, "This is the easiest way to get this out to the kids." We literally were just playing, though. That's, I mean, ultimately what we were doing. So I would highly encourage you guys, like, to take a moment and say, "Hey, Michelle, can I come over? Like, this is the next unit I'm going into. Can we just try a couple things on this? Or do you have a couple ideas you can come over and talk with me about?"
You say come over, is it? You have an office?
She can go to, she's
So,
at Deke. I went over to Deke.
I'm at Deke, that's where we started. That is where all of my materials, all of my equipment is for fabricating. So like I'm going back tomorrow and I'm building a new observation tank for Kelly to grow some vegetables in, specifically based on what she's wanting to observe. So those are the kinds of things you can do. I'm kind of a Jane of all trades. So if you even see something in a magazine, chances are I'm going to be able to replicate it.
Can you go back?
Because we don't have the budget.
Maybe that helps.
Oh, yeah. That
So-
was you on the website. I saw that.
What's on
Real
the
quick
website?
too, our,
Can you go back
so
to
you
that
want to talk about
one
ice
slide real
caps?
quick?
So this didn't shrink down, it shrunk all the way around from every side. So when you're talking about our glaciers and how we're
landforms, that's
affecting them,
The main story.
Yeah.
Storyline?
so that's just
The
something,
one I
final
started out
observation.
with,
So, yeah, that one down there.
this one.
So I think when I look at this, I'm like, oh, where's my weaknesses as an educator? Like, and I've talked with you about this before, there's a very elementary thing about the storyline, that elementary teachers do where they introduce stuff to kids. I will struggle with what are kids doing when they're dialoguing about it at the table? What's the device that's gathering that information that they're talking about? Does that make sense?
I get where
Is
you're
it a
coming
sheet of, what are they doing?
What is
You know
keeping
what I
them on
mean?
track?
Thank you. And that's where that high school part of my brain kicks in, like, well, they've got to have something in front of them, that's where I know my weaknesses.
Being hybrid, well, actually, it happened with Melissa. She came to observe me and she couldn't make it, so she's like, can you just film it?
Yeah.
So I did that, and I literally gave a group of kids my phone and let them walk around with it and record themselves, and it was amazing. So now what I've started doing, because I'm hybrid and I have some kids at home and some with me, I make them, when they have discussions, they have to turn on their camera and they have to record their conversations together and submit it.
So
And
she just
even if they're working on
Yep.
paper, they're still recording themselves.
Proof of their dialogue.
and she
for
did
the
this
dialogue.
with the thermal energy the other day, and then sent me, because I was only able to make it in for the first part of the lab, and then I had to leave. So she sent me their little discussions afterwards, and it was crazy. Like, you got two. In fact, this was what I was. I don't know if I remember if I said something. It was, she had two kids that were up in the front of the room, totally. Like, I was like, they are not paying attention at all. But then they'd pop back in and they would like pipe in with her, like, and saying certain things, and their dialogue was amazing. I was like, oh, okay, they are getting this. You know what I mean? But like, if you were to give them this sheet of paper and just say, this is what you have to turn in, how many of our kids are like, screw that, I'm not doing a piece of paper, and then you don't get it. But when they're able, and I've also, one of the other things that I really loved with this is our kids that are struggling with the reading and the writing. I mean, you guys have kids that are coming to you, especially now with the lovely pandemic, that are 3 and 4 grade levels below where they're supposed to be. And so that barrier, it's not that they don't understand this, they have the knowledge, they can't get it back to you because they can't read and write. You know what I mean?
Mm-hmm.
So is that truly, that's not assessing their science knowledge, that's assessing
It stymies their science
This
knowledge.
goes
Yeah.
Because
back
now
to,
suddenly they're afraid to participate.
when I, at the very end of this, why I make them do a video, to explain what happens. So these are the kiddos, that's my son back in 4th grade, he's high school now, but, the language they're using is amazing. Like, you can, understand that they grasp every concept about everything I taught, every little investigative
So,
lab
like, I
we
think-
did. But, and then there's kids that were like,
And
way off.
And I think what's key here too, when you're assessing, is that investigation, they've set that up. You've given them all the tools, and they've developed their investigation, and they have the results to share with you, and they have the verbiage, and they have the understanding, and they can share that back with you through their own investigation, because they've been through enough investigations on the topic from every direction, and now they have a true understanding, and they can basically practice it.
And last week I had to assess the kids in science, and we just skipped the whole paper pencil thing. Not that I still won't do it, but we did another investigation back to our phenomenon. We went back to the phenomenon. I put in different parameters. We did it together, and then they had to answer, and that was my assessment. Did they get it under these new parameters? So it was pretty amazing.
So like you gave them, because you still do, you have to have like something for them. You can't just like turn them loose and go, okay, here's a camera and here's an investigation, go
Sure.
for it. I understand what you're saying,
Yeah.
RJ, is that you gotta have some driving force. So did you give them like 3 questions? Because I
Yes.
noticed,
Yeah,
Yeah.
you give them,
They had 4 questions to
there's some
answer.
kind of
Okay.
constraint on it, yes.
so they knew like by the end of this they had to have, you know, this film, like they had to have their discussion together to record to answer those so that they, you know, they knew which direction to go
Sure.
into. Does that answer what you're asking?
You know, it is, it does, you know. How about when they're asking a bunch of questions that they wanna find they're creating their own phenomena, right?
Right.
So how do you gather all that and go, okay, well, that's gonna be the next lab idea, like, you know what I'm saying, like,
maybe
or
I
do you
just-
typically have
I
5 or
could've
6 of
missed
the
it.
same ones and you're just using those?
So, both. So if your students come back and they have an investigation that's valid, they have documentation, here's why they wanna do it, here's the kind of materials they're gonna need, and here's what they're investigating, I'm all about that. I will do anything I can to get those kids what they need to do that investigation. Can't happen every time,
Sure.
but the majority of time, as long as it's not, I gotta have a couple of days to
Sure.
round stuff up, but I will do everything I can to make sure they have in place what they need to do that investigation, if the investigation seems valid.
And then this is one of, like, from my perspective, like, I'm right there with you. I'm like, oh my God, how do you plan this out? Like,
Sure.
you know, I'm thinking, like, I can't just call you at the last second, like, oh, Johnny in class came up with this, we need to do this tomorrow, or
Oh,
next
it
hour, you know what I mean?
happens.
Well, she's very good, and she will
I
do.
need hot plates on a Monday, she had them on Tuesday.
I know,
they
so,
worked
like,
out.
she is very, very good, but, like, you can also turn those into, like, I mean, you have an idea of, like, okay, these are the main, like, investigations I'm gonna do. You could alter those throughout it, or you could just stick with those, and then you challenge the kids when they bring those things up. Don't stop them. Say, hey, this is our challenge for tonight, or by this weekend, I want to, like, go home, see if you can do this, and put some of that back on them. That's where we're looking at pushing those kids to that 4. And I've talked with you a little bit about this. I haven't talked a whole lot about this with you, but RJ's been asking me, like, well, what does a kid have to be to get to a 4? And that's what, in our conversation, it's they truly have to be able to take what it is, the knowledge, and apply it to something else, or be able to teach it to someone else. They got to have it. You know what I mean?
Yes.
And so those are opportunities where they would be able to do that kind of stuff. And you have, like, I think the biggest thing for teachers is you're letting go of some of the control of we're all on the same page, we're all doing the same thing, all at the same exact time. That's not really science. Like, it doesn't really happen that way. And so I'm not asking you guys to, like, because if I was just like, we're 100% switching right now, this is what we're doing, like, you guys would be jumping off bridges, you know what I mean? I would be jumping off a bridge with you, and Bilby would be, like, pulling us back in with life ropes, but
No, I'd probably be pulling hair out.
But what I want you to do is take one of the units that, like, maybe, and not for me, I told, like, Brandy Olson, I was like, take the unit that you are most comfortable with, that you understand the most, so when the kids do start getting, like, here and there with stuff, you're comfortable with it. Take that, get with Bilby, and say, okay, I want to go through this whole storyline process. That's what I'm encouraging you guys to do right now. I'd love for you to do one of these before the end of the semester, like where you really dive in and you've done the whole entire storyline right from the anchoring phenomena, and you do a couple other little investigations throughout to tie it back in. The other thing is our resource of MOSA MAC. It's a great resource. It's not our curriculum. I like MOSA MAC for its, what are they called? The make and the solve, the make, yeah, those at the end. But for what we're doing, I wish we would flip it and do one of those at the very beginning, and then do the teaching, like bring the teaching back around to that, and then you could use one of those as an assessment at the end. Are they able to apply all that knowledge on this new, like what Kelly was saying, on this new experiment, or on altering it in a different way, different parameters, different variables? Does that make sense?
Yes.
So that would be the other thing I would challenge you guys to do, is take a MOSA MAC unit. You don't have to be super comfortable with it. All the information's right there. And if it has a good make or something like that, then use it. If not, ask Michelle. She's more than capable, as we all can see, that she can come up with something for you, and flip it. So there's 2 things that I'm really asking from everyone. I'm not, it is super duper overwhelming to like go, okay, Melissa expects all of us to change every single thing we're doing. That's not what I'm asking for at all. I'm asking for us to try, to get our feet wet, and then to share. So like Michelle and Kelly got together and I helped a little bit with sharing this. This video is gonna go up on our, in that science shared folder. If you guys are doing something super cool that you know is awesome, I want our group to see this. We're gonna continue to keep doing these every so often, so I'll keep getting back with you like, okay, what's our next 2 units that we're coming up with, so that she can, pull her resources together and we can throw stuff out to you. You guys are so freaking busy, especially in the year of a pandemic, and you have so many other things to worry about. I don't want you to stress out about coming up with all of this stuff. I just want you to take the stuff that Michelle can come up with for you and then use it with the kids. So,
And I can be an extra set of hands. If it's a labor intensive,
yep.
I can be an extra set of hands. I have no problem coming over and spending the day and being in the classroom and playing with the kids and backing you guys up in whatever you're doing. Whatever you tell me to do. So I've done everything from co-teach with Kelly, to do demonstrations, to slide it under the door and disappear. So
And sometimes if I don't feel extremely comfortable doing a lab or whatever, because like I don't totally understand it, like we've talked about it, but I don't completely grasp it, I have her come over and do it.
And I have a strong engineering, architecture, that type of background. That was originally my direction years ago, far too long ago. If it's something in that respect, that's just the way my head clicks. So, like when you need a little house or something, I can pop that out in about a day. So, please don't hesitate. That's, I think, the biggest thing for me. And the other thing Melissa was talking about, don't worry about doing anything other than just one really good phenomena that has a really good conversation.
Yep.
So with all the teachers I've worked with in the last 8 years, I never ask them to do any more than just one. Do one, and just do it really well. Just do one. And if you don't do anything else the rest of the year that's good, you got one solid. But you learn so much through that, and you slow down and you do it really well, that it starts to make sense, and it starts to feel comfortable. And then the flow and the routine of what phenom-based science looks like becomes almost natural. It fits.
And it's super fun and crazy to see the conversations that the kids have. I mean, it's like that right there. It's like, Ben has asked me to work with this lady and all this coaching stuff and coaching on feedback and just to make me a better coach, to help you guys out. And like doing this, like, I mean, this is my 8th or 9th year as an assistant principal. Like, if that's not burnout rate, like, I've, like, exceeded it. Normally, they don't last more than 5 years, and they're like, I gotta get out of here and go do something else. This has, like, totally rejuvenated me because it's fun. And, like, you get to see the kids, like, light bulbs going off and smiles back on their faces. And we're not arguing with kids about, like, did you get your vocab worksheets done and this, and you know what I mean? Because they're like, I know what that is. This is, and Miss G, come over here and look at this, and this is going on, and this is going on.
And they also want to do it.
Yeah.
And this comes with a certain level of responsibility as a student.
Yeah.
You want to be a part of my lab? That craziness over there?
Yeah.
You can't bring that over here. So you can leave that there if you want to come be a part of this, because that's where everybody else is at. And this is pretty cool what's going on over here.
Mm-hmm.
And behaviors, we've proven.
Yeah.
Over and over again, behaviors will decrease.
So one of my struggles, I think, is that like I did the thing with the 7th graders is just amazing with hot plates. There's like 9 hot plates running around there and no problems.
They only get burnt once, they won't do it again. I
Yeah,
don't know why
everyone
everyone's
does
so
the same.
mad.
Natural
consequences.
Everyone's gotta feel it,
Yeah.
But
Sticks for a little while.
Back at home when you're.
I can do this and I can do 3 and 4 phenomena, but they still don't have those assessments in place that are like for next generation. There's not very many 3-dimensional assessments out there, and then that makes me go, am I
I think
crossing my
because
T's and dotting my I's on this stuff because the kids are having fun and they're all engaged, but I also gotta like move that.
But I think what you're thinking about is assessment is defining what NGSS is too much. NGSS is very open-ended. So here is your end result. It's not saying, I mean, other than hitting on the DCIs, the disciplinary core ideas, as long as you're getting those and those kids can practice those, your assessment is really open-ended on what it looks like.
So these are the assessments, this assessment
Right.
piece, right? So what I do is, at the end, can they do these? Can they explain them? You know, using the terms and the ideas, these ideas. And so, to me, it doesn't matter how you really assess it, but can they
I find
prove
less
that
and
they
less.
can do this?
I find less and less teachers, state of Michigan, across the country. I'm working, talking to some teachers in North Carolina right now, teaching middle school science, just to try to bring myself on board with you guys. And very, very few are doing a written assessment. They model their assessment. They show it through practice. So, you know, it's a personal judgment on your part as to whether or not they actually understand that standard based on what you've seen them display to you, feedback that you've got. So,
And I will tell you this, once hopefully someday this pandemic is over with, the next area that the district is going to be looking at is assessment. And so at that point, we will be getting together as a group, and then we'll be making up these common assessments. And so, so I don't want you to feel like you have to have this huge, amazing thing right now. We've talked, like, if they can prove to themselves through this lab, is that an assessment? Absolutely. Like, so you're looking at those main things that you're pulling out of your daily learning targets. Like, okay, so there's like major vocab that the kids need to understand. Show them something, and then they've got to be able to pinpoint that out. They get it. If they can do that, they understand that concept.
Like, were you able to watch that video? This one right here?
with the pinball machines?
The dialogue about, I don't remember which one it was, but the dialogue between two kids at one point, I'm like, this is crazy the
Yeah.
way they were conversing. I don't remember if it was that one or not, because a couple of them I couldn't watch, so
Okay, no, that's
forgive me
fine.
for not knowing, so, you know.
But that was literally how I assessed them.
Yep.
Okay.
Well, and
they
that's
went out
like
in the hall
Kelly's
with
big
me
thing
and
with
I
like
ran the video
those three
about-
questions over the houses that they were working on. She was looking for three pertinent things out of that, and the kids had to be able to explain it with the information, so she had her success criteria. You're probably hitting some vocab, I can't remember what they were off the top of my head, but, they're obviously looking at certain vocab that you want them to use and make sure they understand a process of how something works, and then maybe applying it in a different, that next step or that higher level thinking is applying it into maybe a different scenario or comparing two things, or where else do you see this type of thing in your world? That's fine. That is okay. And then as far as like tying this in with all of our lovely state mandated testing, which we have no idea if we're going to do that or not yet. When you look at the science stuff, a lot of it is like what you and I've talked about. It's the graphing, it's data, it's understanding and reading things. That's just stuff that you're going to naturally be doing when you teach all of this stuff anyway. You know what I mean? So,
Yeah, you could be graphing right here. We got thermometers up front.
yep.
Graph out your time differential and temperature.
That's what it was. That was what killed me. Is they were taking the temperature every 2 minutes, and they had this cool program that Michelle found for them where it literally automatically went right into the computer, so it graphed. They had a line graph that
We
was
actually
coming
have
up.
temperature probes from Werner. What do we got? 12 of them.
It was
You can
super
hook them
cool.
right into their Chrome
Yep.
books, and it will build a graph. They can set the parameters, the time, the rate that it's reading, and it will build the graph out.
And so like these two little guys over here, they're like literally screwing around with a backpack, like totally normal middle schoolers. They weren't disrupting the class, but I'm like, they have no idea what's going on. And all of a sudden, the one kid, like Kelly's like, what do you notice? And the one kid pops up, he's like, oh my gosh, Miss Swales, it's like every single time we check, it's another degree. There's a pattern there. And I'm like, oh my God, he freaking used pattern?
Yeah.
And he knew the math that was in there. Like he had done all of it. And I was like, never mind, he's paying attention. But it was interesting to him, and he was looking at it, So, but the kids were really, and then they were asking her like, well, if we like move the thermometer up top or the probe up top, heat rises, and she wasn't going there with that. She didn't expect for that to happen, and she was like, yeah, you're exactly right, but our house only has one spot where the probe can go, but that could be something else they could have looked at later on.
And they wanted to know about Kelvin.
Oh, that was it too. Yes. One kid just was like, "What's that? What is that down there in the corner?" And yeah.
My unfortunate thing is I see them one day a week. So
Yeah.
right now the ability to go
To really
very
review.
far beyond is kind
Yep.
of.
Yeah, you'll be surprised, once you start doing this, quite often, they will go far deeper than you
Yeah.
anticipated you were gonna go.
Yep.
I mean, sometimes you're having to say, okay, that's really cool and I wanna know too, but we need to get kind of back on the road.
And if you
Going off track is great.
yeah, but if you
Doing
get
that here
that,
and there, but coming back is.
don't squash that. Have a parking lot in your
Yeah.
room. You know what I mean? And say, "That's an awesome question. Go up there and put that up. When we get some extra time, we're gonna go back to that." Or make it a, like a, "Hey, whoever figures out the answer to this tomorrow's getting a candy bar from me." Oh my God, what kids will do for a freaking candy bar? You know what I mean? So
I've pulled that one a lot of times.
Yeah.
Okay, tonight's homework is
Yeah.
this question. First one in tomorrow morning with the correct answer gets the piece of candy.
yeah, Michelle over at the elementary schools has what is it? A question of the week?
Oh, I
or-
used to put out, we don't have it now, but I put a board and I put out a science question of the week in the hallway. Remember that?
Mhm.
And I would have kids coming down from kindergarten to see what the questions, sometimes it was math, sometimes it was just a riddle, but generally it was a science-based question. And I would catch adults out there. And then they'd be writing their answers,
Yeah.
so,
Okay.
you'd be surprised how much they really wanna do it. It's just getting it to them.
Yep.
So, and I'm bringing it to you.
Yeah,
All you
so
gotta do is just
the
tell
whole
me what.
point of this in our little brain ideas was not to overwhelm anyone, not to freak anyone out. We're trying to make it easier for you guys because we know that this is a monster. I think I told RJ and Michelle, I cried after the first time I went through the NGSS training. I was like, I have multiple degrees and I don't know what the hell they were just talking about.
Sure.
What is that? It was so overwhelming and and I'm not gonna lie, back then I jumped ship and I didn't go down that road. I just kept doing what I was doing. And I did a few cool things, but I didn't do anything like this. And my kids were not, yeah, they understood some stuff, but they weren't excited about it. They weren't, I mean? I felt like it was forced. And so when you can get them excited about science, you're going to get a lot more out of them. So, and they're squirrely middle schoolers, and if you can't, they have the attention spans of a gnat, and if you're not, trying to keep them entertained and getting them hooked somehow, it's a struggle. I mean, you guys know that. You fight the battle every day. So, I thank you guys all so very much. If you have any
Great,
questions,
thank
please stop by. If you want us to look into something else for you, please let us know about that too.
If you wanna come to Deke and play, and just to even see what I can bring to you,
Yep.
where everything is stored currently. I mean, the ultimate dream is in a year or two, we're gonna be doing this right here, everything will be here. But right now, that's where the materials are, that's where my tools are to help you. If you wanna come over and see that and tour the new makerspace, it may help even to stimulate some ideas in you of what you'd like to do.
So I am letting you know one of our next staff meetings, our real legit staff meetings, we're going to take a field trip over to Deke so that you guys can actually see what that's like. It's on a much smaller scale than what we will eventually have that they're building, that they're going to start this spring. But at least you kind of get, because I didn't know what she could do until I got over there and really saw everything. So and so I want you guys to start thinking about that, because when we get that new building opened, I want you guys in there all the time. Michelle will be there, and so the whole point of that, which I didn't understand this, she was like, Melissa, I'll just have stuff set up, and so that they can bring stuff in. You do the teaching, and you're
I
not,
set it up, I clean it up.
you're not worried about all
You
of
just
the
teach it.
setup, takedown, and all that kind of stuff.
That's wonderful because she'll have everything ready and set out. You just go in and get to it.
Students, if they're doing independent labs, those will be pre-set up on trays. And when they're done, everything goes back on the tray and you guys walk away. So-
How's the logistics of that room? Is there we have a couple different classes, or say
So the only classroom that legit will be down there every single day. Loader will be down there with her art. She's gonna have an art area. Then there's rooms for there's breakout rooms.
Right, there's a main room that's gonna be like a maker environment.
Yeah.
That's where you can do a lot of your messy building and I would envision, based on the square footage I saw, you might be able to have 2 classes going in there at the same time. And then I believe there are 3 individual classrooms, little satellite or breakout rooms.
And one's like
Yeah, and I think we're going to make them, like, one will be life science based, one will be, set them up so that if you're working in life sciences and you need to do a lab specific, or, all our plants are in there.
Yeah.
So we've got a greenhouse window going in here, and you can go in here and you can grow things, and this is where you can do the labs, and all the equipment you need to do that is in that environment. I don't know for sure. I've only seen drawings.
Me too.
So
That's the idea, though. Is that
and I
there's
will-
a big area with some, like, I
Yeah.
think it is 3 small areas.
The small, but enough to take your.
Oh yeah, like a
Right.
class.
Yeah.
Yes.
I
Yep.
think our biggest thing is based on how many science classes we have will be the logistics. I don't see you being down there all day, every day.
No.
It's probably gonna be a schedule, so it may be a thing where.
Kelly's already checked it out.
Yeah, Kelly's
so
moving
you're gonna
it.
have to arm wrestle her for it.
But it might be a lab and content in your room.
Yeah.
So you come down and you experience something, the phenom happens, you do an exploration, you come back to your room, this is where the conversation's happening. And maybe it's whatever you did comes to your room on a cart. But we want the kids in that environment as much as possible because we want them to experience that. But the logistics of having so many science classes go through there, based on what we're getting out of our budget constraints, we're gonna have some scheduling issues. So you're gonna have times that you can and can't be in there, okay? It was not what I originally asked the architects for, but again, we had budget constraints, so.
It's
My
still
dream was everybody
leaps
had
and
their own
bounds
room right off
above-
a big spot,
Yeah.
so.
Well, and I mean, we have poor. I think it was Beth 1 year. Like they're teaching in carpeted classrooms, no sinks, no. I mean, like you couldn't
Yeah.
ask for a worse spot than where some of you guys are.
I was bringing my coffee pot in last year to brew hot water.
Yeah.
In between every class, I'm brewing the hot water
Yeah.
in the coffee pot.
We'll make it happen one way
Yep.
or another, that's my theory.
So I just want to get you guys like the end of this year. My goal for you is to get your feet wet in this stuff, get you a little bit more comfortable with it, get you to see the maker space. Because as soon as they open those doors, I want us to hit the ground running. I want us to enjoy that. I want you guys to have fun with it. I want the kids to love it and be proud of it, and want to be in there. So that's the
And the
ultimate goal.
community,
And the
eventually we
community.
want the community in too.
Yep.
That's where we get, because a lot of what I do is gonna be upcycle. You'll see a lot of things come through. I upcycle anything I can get my hands on.
She's a garage sale queen.
Community involvement is huge when you're doing STEM.
Yeah.
Because you need supplies. I need cardboard. I need water bottles. I need canning jars. I need fish tanks. I'm sending out emails. I'm petitioning. We'll do maybe a family night and we'll put out a list of things we're looking for. And then I need a room for junk.
Mhm.
But that is what I work from. So, like, donated. You know, so, donated. Root beer sale. You know, this was, we planted a garden, we had a little sand left, so I'm kind of I'm a hoarder here at school. At home, I try to purge at home, but probably because I do it so much here, but no, I have a tremendous amount of resources that way, and community involvement will help us get more. Also get you some financial support sometimes.
Mhm.
I have a benefactor at Deke that has no problem, if I need, dropping a $1,200-$1,500 check off.
Nice.
So it's finding those key people.
Yep.
That can benefit you guys in what you're doing, so.
So in respect to your time, we've already kept you longer
too
than
long.
what we planned on, but thank
Yeah.
you guys so much, and seriously, please, please, please reach out to any of us. If you have any questions, want to try something, do not be afraid to fail. Don't. We're teaching kids to fail, you learn from your mistakes, that's how you learn. So, and like invite me in to ask, just, hey, can you come in and try this out with me, and please, like that's yes, 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 and yes, that's awesome. So
I'm at Deke until 4 o'clock every day, and I'm willing to stay late if you want to stop by on your way home.
All right.
and I'll let you guys know when we're going to be taking our field trip. But thank you. So unless you have any other questions,
Thanks, Michelle.
Bye, Beth.
Thank you.
bye,
You're
Beth.
welcome.
Are we doing the
Uh,
recommend?
Do you have any questions?
I
You
cleaned
good?
it up.
You got a cig in here?
No, I got it.
You good?
You
All
guys,
right.
as soon as everybody's
Thank
out,
you.
then I can do my quick clean.
Bye.
Our kids eat lunch in the room, so we have these
Oh.
nice.
So I've gotten pretty good at cleanup process. So this will go
Am I good to
outside.
stop this?
Yeah,